So welcome again, folks, for those who have been hanging around or those who just joined. This is Paresh Motiwala from Houston. And we have Kevin Wilkie coming up now, and he's going to be talking about, I guess, data types, right? That is what he's going to talk about. We always struggle with that a lot, so I do personally believe it will help me. And if you like to go ahead and scan this QR code and go ahead, and if I can join the team, that would be really great. I have already joined and I immensely benefit from it. Thanks to our sponsors, which is absolutely fabulous to have that here. And without the sponsors, it's almost certainly impossible for us to do anything at all. Okay. So thank you, Stream, Power BI Sentinel, Exelegent, and Q Associates, and of course, Redgate, Packet and Redgate. So I think some of our great friends there. Okay, and then without much ado, yes, do go ahead and register your names in case you're interested in picking up one of some of these awesome prizes. I registered 10 times already, so cool. And Kevin Wilkie should be here now, and he's going to talk about, he's a Sherpa of data. Who could have thought? Have you been to the Mount Everest, Kevin?
I have not, sadly, but I keep trying to get there.
Yeah, I think maybe we can go together. We can have DBAs kind of on the top of the world or something like that tour, right? That should be awesome.
I like this idea.
Yeah. Cool. So go ahead and thank you once again, folks. I would like to now pass on the control to Kevin. If I can find him ever. Okay, so he said, look at people and go to Kevin Wilkie. Kevin, where are you?
First, you're going to have to make me a presenter.
Yeah, I know. So I'm just trying to find you in the people here. Why can't I find you? Kevin Yon is what it shows. Oh, Kevin Wilkie, now I find you. And I can make you a presenter. Yes. And the power is all yours now.
Awesome.
So go ahead. This is something that really bugs me a lot. So I'm going to pay much more attention to this one. Definitely.
All right. So I'm going to share my screen because everything is obviously on the screen.
And how would you like to take the questions, as and when they come, or?
Just as they come.
Okay. So I'm just watching the chat room here in case anybody has questions. And then 10 minutes before the end of the session, I will go ahead and mercilessly ping you about it.
Perfect. I expect nothing less.
Cool. Thanks, man. Appreciate your time, sir. Go ahead.
All right. So today, my friends, we are going to talk about finding the right data types. Very simple. We've all messed with data types pretty much all our lives. Today, we're going to find out what we should and shouldn't do, and if there are better data types to use, and examples of why we shouldn't use some of those. So with that, this is me. I am Kevin Wilkie. I have been working with databases for over 20 years. Well, at this point, almost 20 years. Co-organizer of DBA Fundamentals and this great group you're actually part of, the data-driven community. I've held many titles over the years, such as ETL developer, production DBA, BI associate. Let's just say that if it's been a database, I've played with it at some point. So let's get down into it. Data types. What are they really? They're just a classification of what type of value a variable or a field can hold, as well as what type of operations can be performed on that value without causing any errors. That's a big thing that we have to remember. It's not just what type of value is in there, it's also what functions you can actually do on the data itself. So we break down our data types into several different categories. I'll break them down this way. Pretty simple. Character strings, exact numerics, approximate numerics, date, time, and other. So with that, let's just get right into it because there's a lot to cover. The character data types on SQL Server. there's a few in here. We have character fixed width, variable character, which varchar, which means variable width, inchar, which is the Unicode fixed width, and invarchar, which is Unicode variable width. Then there's one of my favorites, text, which Microsoft has been saying is going to deprecate since about 2005. One day, maybe.
I think Kevin just lost his connection, guys. Just hang in for a minute. I'm
It's so
sure he'll
weird.
be
You
back.
taught me that for a reason.
Yeah, I don't know what happened, but hey, welcome back. And I think I'll have
Hey,
to
at least it
make
didn't
you
take long to figure it out. Always a good thing. All right, so text. All right. Let's do this one. Let me make sure I'm doing the right one here. This one. Okay. All right, on Oracle, we have kind of the same things. Char is a fixed width. Varchar is a variable width. Varchar2, which is also a variable width. Inchar, which is a Unicode fixed width. Invarchar, which is the Unicode variable width. Clob, which stores 8 terabytes of character data. And inclob, which stores 8 terabytes of Unicode data. So you see the slight differences between SQL Server and Oracle. There's a few. Big one being Varchar and Varchar2. On Oracle, you should be using Varchar2. Do not use Varchar because it's been deprecated. But they still have a lot of code that uses Varchar, so it's not really deprecated. So you just mess with it. Everything should be using Varchar2 now because, like Microsoft, they can truly deprecate it at some point in the future, but at least until then, we're kind of stuck. All right, so with that, I actually want to show a small demo I have on characters before we get into numerics. All right, so I'm going to be showing all my stuff here on SQL Server just because I actually have a SQL Server. It's easy to get a hold of. Oracle, not as much. All right. So first we start off with just a simple table. Notice here, its first name is varchar30, which is I'm requiring. Last name is invarchar, so it's null. And a full name, which I'm just going to update in a second. All right, so first off, we just go ahead and create our table. We insert into this table first name and last name because we'll update the full name later. Fred Flintstone, Barney Rubble, and an awful string that you hope nobody ever actually does, but it does prove a point here. So when we go to insert the data, it shows that the string or binary data will be truncated in the table. First name, truncated value, and it shows exactly how long it is, which for those of you who are on anything before, I believe, 2020, that edition, it doesn't show this for you. It just says, yeah, something's been truncated, good luck, figure it out. Some of the newer versions do show that, thankfully. So with this error, if we looked at it, you'll see there is nothing there. All right, so that's good. So now we just do this portion so we can actually have some good data to play with. Then we go ahead and update our table so it shows full name, last name, and first name. Well, we're just doing the normal last name, comma, first name. We're going to look at some of this data. All right, Fred Flintstone, 16 characters in length. Then Barney Rubble is 14 characters in length. Yep, nothing untoward there. We're all good. All right. So now we want to do something fun. Because we know that invarchar and varchar are a little different. we want to see the true difference in some of this stuff. So when I run this, you'll notice first name, last name, and then the length of the first name and data length. Here's a function that not many of you probably use too often. This one actually shows the length of the data itself. So thankfully, in the case of varchar and for first name, it actually shows that length and data length are the same. When we get out to last name column, you'll notice that it goes length is 10, but data length is 20. That's because of the varchar part there. So please be aware of that as you're looking at some of this data, because this is obviously the size of how much space the actual thing, the actual field takes to do it. So be aware, because that's a fairly big thing. All right. Let's go to numerics. This is exact numerics now. So we're truly going to store exact numeric values. In other words, no scientific values. First one we look at is bit. It stands for the values true and false. Most of us realize that and have played with it for quite some time. In reality, it's 1, 0, and null. Now, some of you may think, no, bits 1 and 0. Nope, you can put a null in there, because if you allow nulls in the field, you truly have made it a ternary. So it will actually allow for the 3 values, 1, 0, and null, if you have it allowed such. That's why for most of your cases, well, for all of your cases where you only want zeros and ones, you should always make it not null, and then provide a default. When converted from another data type to a bit, any non-zero is true. So let's say you're shoving some data in there that's -7. That's true. Even the string heaven is true. It can also convert true and false into a bit. True and false, thankfully, it does recognize the word false as 0. So it will change, it will shove that in as you're going through. I believe, yep, okay. All right, so decimals. Well, in this case, we're just doing integers. Thankfully for this one, SQL Server and Oracle both allow the same values, the same size. They just call it a little differently. In this case, you'll see integers, basically the same thing on there. -2 to the 31st power and 2 to the 31st minus 1. For integers, short int, small int are both -2 to the 15th, or in max out at 2 to the 15th minus 1. SQL Server to Oracle is big int or long int, -2 to the 63rd power, or max out at 2 to the 63rd power minus 1. So yes, they are rather large, at least the ones they allow. Now, Tinyit. That one's a really, really small thing you should be very aware of if you don't want to allow too big of numbers. I use it a lot I have a case where I am only allowing the numbers 0 through 12. Sorry, 1 through 12. This is one of the cases where I can use Tinyit, and it actually will save a ton of space on the server, because I'm allowing I only have to use such a small amount of space anyway. So why not just do Tinyit? It is only from 0 to 255, and the important thing to realize about this one is no negative numbers are allowed, period. Now, numbers with decimals. SQL Server and Oracle both need to know 2 things when dealing with a decimal number: precision and scale. Precision is the maximum number of digits stored. So I'll show examples of this. For let's say 8.12. That's a precision of 3 because there are 3 numbers shown there. Default for SQL Server is 18, while the default for Oracle is 38. Yes, that's rather large. Why? Who knows? Just because they wanted to make it large. Hopefully most of us won't ever have to play with numbers that truly max out or go over this default, but it is available in case. Scale is the maximum number of digits stored to the right of the decimal points. So for example, in my example earlier, let's say it's 8.12. I have 2 numbers to the right of the decimal point, so therefore the number is 2. The good thing about scale, default is 0 for both SQL Server and Oracle. At least it's consistent between the two, so you won't mess up too much when you go between those. Now, this one is where the numbers get very different in what they can hold. SQL Server, decimal and numeric are the exact same thing. Why they have both of them in there, I'm expecting it's something from Sybase days, because it seems like it's always been this way. It's truly been negative 10 to the 38 plus 1 to 10 to the 38 power minus 1. In Oracle, it's short decimal, which is the equivalent to decimal on SQL Server. And decimal is 10 to the 308th power. Number is 10 to the 125th power. It's a lot. Hopefully, you'll never have to deal in any numbers quite that big. So let's actually, before we go to money, let's actually look at examples here. All right. Here's stuff hopefully you'll have seen, played with, been scared by. For the below query, if you were to run it in your head, what data type would you have? So for me, when I run this, at least in my head, I'm thinking decimal. So what does SQL Server give us back? That's right, integer, because it's not, it's just not. So the reason for that is because both of these are integers. So if I was to actually put this one as 1.0, and it changes it to 0.5. Otherwise, it just continues on and thinks it's doing integers because of precision. Right or wrong, just remember that's how it's got to be. All right, now that we got through that one, what data type should SQL Server return for these? Much bigger numbers, but we know what the answer was up here because both of these are integers. So what does it do? A combination. Yeah, that's because this is that fine line between integer and big int. So when you change over, it actually becomes into big int category, and it completely changes how it does configuration. So just be aware at some point it's probably going to change, especially when you're getting big numbers. So yeah, be prepared when you're playing with decimals and figuring out division, or multiplication, either one, because it can do things like this. So what happens if you go outside of the limits specified for some of these things? So I'm going to create another table. Create my table, insert into my table I just created, number 254. Pretty simple. Everybody can remember that, hopefully. Notice it's a small number. It's called small number. It's a tiny int. So remember, it's from 0 to 255. Looking here just to make sure that I have nothing up my sleeves, because I have short sleeves on today, but that's neither here nor there. We update our table. You set the small number equal to small number plus 2. So that will bring it outside the line, crossing at 256, at least in our head, and making it into not a tiny int anymore. So what does SQL Server do? It thankfully gives an error like it's supposed to, saying that the it had an error value 256 is what would happen. Notice that's also a slight thing when you're trying to pay attention to what's going on, because you have to look for the number that it became, not the number it was. Something to pay attention to as you're going through these things. All right, more things with decimals. All right. First thing, we're going to create a table, decimal data type. Pretty simple. One decimal, one number. We've just made it decimal and numeric just so we can show that we can, and there's no real difference between the two. We have a with scale, just for fun, decimal 7.4. One thing of note, on Oracle, you can actually create it with a negative scale. Yes, that does happen on Oracle, not on SQL Server. This is so you can have, in this case, since I have -2 as a scale, it actually shows up. It will only show up data that is precise to the 100 position, not to the 1 position. If you don't care about it, Oracle doesn't either. Something to be aware of as you're playing with stuff. All right. So with that, I'm going to go into creating, inserting some data into this decimal data type table. 3.2, -4.25, and 9 point whatevers. All right, pretty simple. Select star from, make sure I'm not doing anything funky. So when you look at it, you'll be like, the first time you look at it, you're like, I lost data. Well, that was the fault of the person who created this table, because you created it at 7.4 and this one has 6 after the decimal. So you're already telling it to lose data. Is it a big thing for you? Maybe, maybe not. Depends on what your table is or what your applications are. Something to be aware of, because already you've lost some data, which may or may not be a good thing. So, fun part. How are we affected when we divide or multiply? So I'm going to take my little numbers I've created before. We look at back at our table definition. One decimal, one number with scale. Notice they're all the same, truly the same data type. All right, so we come back with one number, negative number, another negative number. We multiply them, divide them, great. Okay. Now we're going to use variables. Decimal 1 is 20.5, decimal 2 is 27.52. We're going to insert into our table. All right, got nice data. Star from our decimal data type. You see down here, we got the numbers we expected, because when you do 20.5 divided by 27.52, you get this number. 27.52 divided by 20.5 is this, and the last one, those multiplied together gets one big number. All right, so now what does this return? So we're doing the same things. Notice we have our two variables set up here, and we're just going to find it where one decimal equals the decimal 1 divided by decimal 2. I'm going to actually make sure so y'all can see that there is absolutely nothing up my sleeve. Same things work perfectly. So now when I find this, because remember when I'm taking one decimal, which is this one, so decimal 1 divided by decimal 2, we should find it, right? Right. When I run it, I get back a whole lot of nothing. Why is that? Y'all will look at it when you're trying to figure it out one time, probably 1 o'clock in the morning. You're like, I don't understand why this is not running anything. So that's because of the data types itself. Because when you have went to find these numbers, when it comes into here, it comes out 0.74485 something something something. Yeah, and that is not 0.7449 because you have said equal. So no, it doesn't find it. Something to be very aware of as you're playing with this stuff. because it is obviously, if you're trying to figure this one out and then select it, you won't find it. Just be aware. All right, so back to our thing here. Ooh. All right, money. There are actually two different types for money in SQL Server. Small money, which is 214,000 some change, negative and positive, and money, which is a huge amount of money, which I wish I had in my bank account. The positive one, not the negative one. Oracle doesn't have money at all. You just use the number format, call it a day. 19.4 is what they recommend to use. So actually, let's do money here, because that one, I got some fun things as well. Let us drop and create our little table, total money, portion money. Pretty simple. All right, so we're going to insert some data into it. All right, get it all in there. All right, portion total, then portion divided by total times 100 for percent. Great. Now, so just because y'all know me, at least have figured it out by now, I'm going to show you some things that aren't quite right. So let's see if these numbers are right. So we bring up Windows Fun Calculator, because we all know the application's right. We do 124.33 divided by 265.67. That is 0.46798 whatever. All right, so when we do rounding, that becomes 46.8%, not 46.79, because it's off just slightly. If we look at one of these others, I'm going to do this one down here just because 43.16 divided by 46.39, 93.04%. So yeah, it doesn't actually divide right when you throw in a percentage because it's special. But yeah, it's at least close enough for government work sometimes. So it's something to be aware of. As you see here, this isn't right, but this is. You can actually get the number to be showing right, but you'll notice we've had to take it out of money format, and we've had to change it so that the decimal values are far enough along that we can show it correctly. Something to be aware of. All right, so with that, let's go back to our slides. All right, approximate numerics. So these represent real numbers, but they're truly approximation of the real number. Things like floating point. It refers to the fact that the decimal point can be placed anywhere relative to the significant digits of the number. So yeah, so really is things like that are really large, like distances between galaxies, or really small, like distances between atoms. That's where that true floating point comes into play at. So data types you can use in SQL Server are real, which is negative 3.4 times 10 to the 38th power, or 3.4 times 10 to the 38th power. Yes, like I said, really big numbers that you're having to play with. You can also do float, which is to the 308th power. Yeah, like I said, really, really large. And Oracle has the same things, kind of, just different numbers they allow up to. Binary float is the 38th power, and on double, binary double, it is to the 308th power as well. Just for whatever reason, very different number than SQL Server is. I actually believe I have a thing for floating point as well. Let's see here. Nope, the next one I have a time. All right. So SQL Server date and time. Minimum date. Was anybody actually aware that you could do 111? Probably not, because not many people have to actually use that number. Thankfully, most of the time, most of the stuff I've seen is 1800 or 1900. Just be aware you can actually put it in there to the year 1. Do you need to? Probably not. Should you? Almost definitely not. But you can. It's up to the year 9999. Yes, we will have the year 10,000 bug. I'm probably not going to be around to see it. Hopefully some of you will. Date time only is backwards. You can only go backwards to the year 1753 at midnight on January 1st. And 12/31/99/99, almost to the end of the year. 3 milliseconds away. Date time 2, which hopefully most everyone has converted over to using, has even more precision. It actually allows you to go up to, in this case, I'm showing 7. I think that's at least the standard I like to use for precision on date time, just because it shows more precision than you'll ever probably need. Plus, in case y'all of who are actually not using date time 2 yet, please consider it, especially if you're a DBA, because date time 2 actually takes up less space than date time does. This is because they have went back and fixed how it's actually displaying and how it's put into the database, so that it's much cleaner. Yeah, so with that, we go to small date time, 1/1/1900 to, yes, the year June 6, 2079. Just something to be aware of as we're playing with data. Probably won't affect many things you're dealing with, but it can affect some if they're doing that far out in the future. Obviously, time is from midnight to the millisecond before midnight of the next day. And then there's date time offset, which is 1/1/1900 with a little offset with a little time as well. But there is an offset showing for it as well, so you can tell where you're at. And then finally, Oracle truly only has one date. It has, in their case, 1/1-4712, which is the year 4713 BCE or BC, to the year 12/31/99/99, where the precision denoted is actually kind of like I said for date time 2, it goes far out there. Also of note is that Oracle uses the astronomical system for calculating Julian days. If anybody gets really bad off and wants to read that, I fully encourage it, because most people will never have to deal with that. All right, so since we're on dates, let's talk about dates. All right. For date time, I'm going to work with 3 dates. These are dates I did last year. June. So let's rig it up to the future, up to this year. January 14th through July 11th and July 21st. That's what we're going to start comparing, because when you look at these, you'll see obviously January 14th is to January 11th. January 14th to June 11th is almost 6 months complete, and a little over 6 months. But when we run this, it says 6 and 6. This one is not correct if you're doing things that are truly has to be exact. For example, I work in healthcare, where we have to worry about birthdays because it can affect different things on how some of the stuff works. This one is incorrect for us because it is truly not 6 months. It's close, but as we all know, close only counts in horseshoes and hand grenades. So you cannot truly just use this function. There is a case statement you can find online, or you can look on my blog. You'll see exactly how to do this as well. See different things about it. There's also many, many different functions you can get that actually play with dates and how it displays or shows or is set in the system as. If you go through here, you'll notice get date is actually, I believe now it's a date time too. Sys date time is, no, actually get date is only date time. Sys date time is date time too. Get UTC date is, I believe, is also date time. Sys UTC date time is date time too. And then there's the date time offset. You play with these in different ways. Obviously, depending on if you have it on-prem, your get date and sys date time are going to be pretty much the same thing, more precise. But depending if you're in Azure or AWS, you are actually locked into whatever the time is on the system where you have it put. So, for example, my stuff is in Virginia. So therefore, if I use get date, it will actually show them as in the Virginia Eastern Standard Time, which I'm okay with since I am in Georgia. So this is okay for me. I'm just have to be aware of it. I don't want to start comparing things to what it is in get UTC date because that can really mess some things up. Just a word to the wise, we found some people that were doing this on our systems because they were comparing get UTC date to, because they were using the get UTC date for the log, where other places it was using get date for the log. So trying to compare, you're not going to. Just to be aware, you can find some things out like that the hard way. Okay. So now I got a few that I've just had to throw into the other data types because there's nothing quite like them. Binary and var binary, which are basically the same things. Obviously, you can tell from how the strings are named what their difference is going to be. Binary is a fixed length binary date with binary data with a length of n bytes, where n is a value from 1 to 8,000. Var binary is the same thing, but Unicode. Not Unicode. It's a variable length binary data. We also have unique identifiers, which is another term for a GUID. I'm sure many of you are familiar with GUIDs, way too much probably. There's also XML and JSON data type. There is geometry, which is coordinate data, and geography, which is longitude and latitude. These two are actually implemented through CLR, so be aware of that as you go through and set up your databases and data tables. If you don't want your people using CLR, it's something to be aware of. So let's go back to this binary and var binary here real quick, because I have one final example on that one. All right, so we declare our binary variable is binary 2. We set our binary variable to 1, 2, 3, 4, 5, 6, and then we add 1 to it. So what does that come out with? Something that doesn't look anything like what our original number was. If you have to play with this one with binaries for any reason, be aware of that. Adding to it, subtract from it, multiplying, dividing it does not work quite how you originally thought. Something just to be aware of because of all this play. All right. In Oracle, there are a few other data types. Objects, which is as you expect it to be. It's object-oriented programming. So they've actually allowed for all kinds of stuff in OOP that you can play with C#, whatnot. You have your XML type, and you have your row ID, which is a variation of a GUID. And with that, I have come to the end of my presentation on different kinds of things you can work with in SQL Server and Oracle. I actually have a variation on this presentation where I go into Snowflake as well. I'll actually be giving this one later this year at Past Summit. So if anybody has would like to see a expanded variation of it, please come to Past Summit, where I'll be talking through this one with the additional Snowflake usage as well. In the meantime, if you'd like to see all kinds of stuff about whatever I talk about, you can always visit me on my website, serprodata.com, my LinkedIn page, or just hit me up on Twitter or email. My serprodata.com page, I'm usually talking about different things for all kinds of stuff for different functions you may or may not have ever heard of in SQL Server. I'm also starting to compare it to Snowflake. So if anyone's interested in that, please be aware of it. Hit me up, see what kind of things I have out there. It's something that will at least interest you. Maybe something that you're not aware that SQL Server did, or Snowflake, or Oracle. Just see what's out there. So with that, Paresh, do we have any questions, comments, or anything?